Hello, my name is William Douglas, and today I'll be presenting to you information, properties, and common misconceptions about black holes. In the meantime, I'd like to thank the audience for their time, and let us begin. So, black holes, according to Britannica.org, are defined as cosmic bodies with such immense gravity that not even light can escape from it. This is a picture of a black hole, and they range in different sizes, coming from the size of a city to sizes of planets and even stars. Our story begins with Albert Einstein and his theory of general relativity. These were published in 1915, and the equations that were located inside of his theory of general relativity were solved by Karl Schwarzschild. This solution points towards the idea of black holes actually existing. This was disputed at the time, however, many thinking that a law of nature would prevent it. From the 10s until the 50s, a few discoveries were made, but this turns around in the 1960s with the golden age of general relativity. Many discoveries, including quasars. It became clear, according to Scholarpedia.org, that very exotic astrophysical objects could exist. This culminates in 1971 with the discovery of the first black hole, Cygnus X1, named after the constellation that it's part of. And in 2017, we took our first photograph of a black hole. Black holes begin their lives from the death of a star. This is a supernova over here, and it marks the death of a star and the birth of a black hole. In order for black holes to be born, a star must be at least 3 times the size of the sun, otherwise there's just not enough gravity there. What happens is gravity, it crushes the star and core into one single spot. Boom, a black hole is created. Some common properties of a black hole, you have the event horizon. This is kind of referred to as the black part of the black hole. It is referred to as the point of no return. Once you cross the event horizon, you can't escape. Light can't even escape. And then you have the singularity. It's the center of the black hole. This is the point where all of the density and all of the mass of the star is concentrated. One single point. And this white part around the black hole is known as the accretion disks. It's essentially the rings of a black hole. Black holes are kind of messy eaters when it comes to tearing things apart, and this is represented by the matter that is around the black hole. And this radiates and allows us to see black holes. Another interesting prospect or property of black holes is spaghettification. It happens to objects that enter a black hole. What essentially happens is, because of how gravity in a black hole works, the object gets stretched further and further and further until, according to Phil Plait, who is an astronomer in his own right, it becomes narrower than a piece of hair. This matter then gets added to the singularity. However, all things must come to an end, including the black hole here. The way that they die is through a process known as Hawking radiation. Essentially what happens is that over a long period of time, and this is such a long period of time that it's appropriate to call it forever, that it radiates away the black hole until there's nothing left. So common misconceptions when it comes to black holes is that they are massive vacuum cleaners. This is kind of true, but not necessarily true. They only pull things in if you get too close. And once you get into the event horizon, there's no escape. However, if the sun were to be replaced by a black hole, the Earth wouldn't suddenly move towards the black hole. Another misconception is that all stars can become black holes. It's just not true, because not all stars are massive enough to become black holes. You have to be 3 times the size of our sun to become a black hole. Another interesting one that I hesitate to call a misconception is the idea that there are wormholes to alternate universes. It's not strictly false, but it's not strictly true either, because we can't prove that a black hole is a wormhole to an alternate universe. Because if you were to go in, you will die. So in conclusion, black holes are unique for their immense gravity, and there's still a lot to learn about them. Hopefully one day we can venture out and observe these titanic beasts directly. And in closing, I'd like to say thank you for your time, and I wish everyone a good night. Thank you.